My name is Ben Parmer, and this is my project for week 6. So I was originally doing a wide flange shape, and it started getting too complicated, and I was having trouble understanding it. So last week I switched to just modifying the example. And this is kind of a continuation of that, but I modified the example in a different way to try to get a different shape and understand more of what was going on with it. But here's the top body. I have two bodies total. One is a large like platform, and the other is kind of like a post or a tree, you could imagine. But here's the parameterization for the top body, and then the new code for this week is the body 1 map and the F map. So here's the bottom body. I kept this the exact same as the example. Really the only thing I had modified was the top body, and that was just the sizes, and I moved it up and down the shaft of the second body to give me different shapes. And then here's the scalar and vector fields. Is very similar to what we've used before. And then here's my body itself. So it's a platform, if you will, on a post. And then when I deformed it, I just made it deflect down and then move the platform with it. So it kind of looks like, to me, like it's under a wind load or some sort. And then here's the output. So I had a undeformed and deformed length for curve 1, part 1 of 26.7 and 57.8 respectively. For curve 2 of part 1 was 26.7 and 59.9 respectively. And undeformed and deformed lengths of curve 1 of body part 2 are 6.3 and 24.2 respectively. And this right here, curve 1 for body part 2, are what I verified by hand later on. So here's a body 2 parameterization, or in the x1, x2, and x3 directions. For the x1, it's r cosine t. That's a plus, and that's 21 over 3. 1 minus cosine, and within that cosine is z over 21 times pi over 2. And then x2 is similar, but just with sine right here, and then a minus. And then the x3 direction is a 0.9 z minus r times cosine minus sine t over, this is all over 2, and that 2 is multiplying z over 21. And then here, this is the derivative of x1 with respect to r, so you get a cosine t. The derivative of x1 with respect to t, and that ends up with a negative r sine t, and so on. So this is the derivative of x2 with respect to r, x2 with respect to t, and x2 with respect to z. Then x3 with respect to r, t, and then z. And then right here, I didn't show everything worked out because it's pretty complicated and it takes a while. But the deformed length can be found using this equation here, or this equation right here, which is what I used and ended up with 24.2 units. But that's all I have. Thank you very much for watching.